The last question of the paper is the number of possible chiral dichloro products that can be formed when R2-chlorohexane reacts with Cl2 in presence of UV irradiation is. Now, in this question, the problem is the name they have given is 2-chlorohexane, but the structure they have shown is 2-chloroheptane. 1, 2, 3, 4, 5, 6, 7. So that is definitely a mistake. If you consider 2-chlorohexane, then you will get a different answer. If you consider 2-chloroheptane, you will get a different answer. So if we first consider 2-chloroheptane, what they have drawn here, then remember that this carbon has a fixed configuration, that is R. So possible positions of Cl. So Cl can be present here. When the Cl comes here, then this new carbon is not chiral, right? So this will only produce one isomer, and that is optically active. When the Cl comes here, then this carbon formed would be chiral, so it will form two isomers. Those two isomers, this carbon has a fixed configuration R, and this carbon will have both R and S configuration. Now RR and RS, these two are diastereomers, but the RS diastereomer is optically inactive because this would be a symmetrical structure. If you see that from the if there is a Cl on the second carbon, then from both the sides the Cl comes to the second carbon only, so this will be a mesoform. This will be a mesoform, which means this is optically inactive. So we will not count this in the chiral product. So out of two, only one would be counted. Now when the chlorine comes on this carbon, again two will be formed and both will be optically active. Here two will be formed, both will be optically active. Here also two will be formed, both will be optically active. When this H is replaced, then only one is formed, and that is optically inactive because there won't be any chiral carbon. And when the Cl comes at the last carbon, again because the new carbon formed is the new carbon, the Cl bonded to this last carbon is not a chiral carbon, so only one carbon is chiral, so it will only give one isomer which is optically active. So if we count optically active, then 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 9 would be the answer if you take 2-chloroheptane, which they have drawn here. But if you take 2-chlorohexane, then one of the carbon will be removed. So 2 isomer will be reduced. So in that case, the answer will be 7. So both B and C can be correct. Of course, there is a mistake in the question. If you consider chlorohexane, then we are getting 7 optically active, and if we are considering 2-chloroheptane, then we are getting 9. So the answer for this question will be both B and C. So this completes our discussion of KVPY 21 SB S6 stream. Thank you.